Hey Geometries, this is Mr. Bloom and this is 1167, polygons in the coordinate plane. I'm going to get my pointer up here and we'll see what we can do about making those things happen. All right, so when we're working with these polygons in the coordinate plane, you got to keep in mind, y'all are going to be working with our objectives. Students will be able to classify polygons in the coordinate plane. Okay, so make sure you get that down in the objective area. Okay, our essential understanding today when we're working with this, you can classify figures in the coordinate plane using the formulas for slope, distance, and midpoint. And I'm going to give you a list of when to use what as we go through these. So the formulas of the coordinate plane that we're going to be working with today. Okay, first of all, we got the distance formula, and this is x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared, and we take the square root of all that. Remember, x sub 1 and y sub 1, that is a coordinate pair. X sub 2 and y sub 2 is another coordinate pair. Those subscripts are there to tell you, the user of the formula, you need two distinct points. So you'll use this to determine whether sides are congruent or the diagonals are congruent. So you're just finding the length and you're going to be comparing corresponding lengths. Now in our next formula we're going to be working with is midpoint. In a midpoint formula, we've worked with this before. The midpoint of a segment has the endpoints x sub 1 plus x sub 2 and endpoint y sub 1 plus y sub 2, and we're going to find the average of those endpoints. So you have these 2 points, and they're distinct again because we have x sub 1 and y sub 1 and x sub 2 and y sub 2, and those are 2 distinct points, and you need endpoints, and this finds the average of your x's and the average of your y's for the midpoint x, y. Now we'll determine this, the coordinates of the midpoint of a side, and whether diagonals bisect each other, because if they do, they should share the same midpoint or a common midpoint. Now, this last formula is talking about slope. Our slope formula is the slope of y sub 2 minus y sub 1 and x sub 2 minus x sub 1. Again, we have 2 distinct points that we're working with here. We have x sub 1, y sub 1, and x sub 2, y sub 2. And when would I use slope? Why do I have to worry about that? To determine whether the opposite sides are parallel, because if the slope's the same, they are parallel. And determine whether diagonals are perpendicular. If the slopes multiply together be -1, they'll be perpendicular. So let's talk about that. So if I have slope 1 is equal to slope 2, I've got parallel lines, okay? But if I have slope 1 times slope 2 is equal to -1, I have perpendicular lines, okay? Now, we can also determine if the sides are perpendicular by using this idea of perpendicular line slope. Now, let's see how they work. Maybe, if it actually moves on in our lives. Classifying a triangle. Now, we learned about classifications in chapter 5, and we're wondering, is ABC, scalene, isosceles, or equilateral? Now, keep in mind, scalene, none of the sides are the same. Isosceles, 2 of the sides are the same. Equilateral, all the sides are the same. Now, we could use, in this case, I've got the distance formula, and that's one we have to pull out. But because I have a grid, I am going to use a little bit of a shortcut, the Pythagorean theorem, to help me with this one. And remember, the Pythagorean theorem is a squared plus b squared equals c squared, and that is used for right triangles. And what I'm going to kind of mythically think about a right triangle here, and I'll be able to find the segment length of AB. So if I'm looking for AB here, I'm looking for that length. I'm wondering about 1, 2, 3, so that's units, 3 units, and 1, 2, 3, 4, and that's 4 units. Well, this is a 3 squared plus 4 squared. We'll learn about Pythagorean triples, but right now I'm going to talk about the fact that we have to find the square root of it. And that's very much like the distance formula down here, but I didn't have to use the coordinates. I'm just finding the lengths of the sides. So we now have 9 plus 16, which is 25. Okay, and I have that AB is 5 units. Now, the next thing is BC. Now I'm just going in alphabetical order here. And if I'm looking at this, I'm really making my little triangle here. And I've got 3, and again, 1, 2, 3, 4. Hey, that's 4 as well. And now I've got 3 squared plus 4 squared, and I find the square root of this. Okay, and that's again, this distance form, I'm finding the distance between B and C, and I use the distance of my legs to find that hypotenuse. And again, since we've done this already, we already know that this is going to be 9 plus 16, which is the square root. Okay, so that is also the square root of 25, which is 5. So right now, I know that BC and AB are equal. Now, right now I have an isosceles triangle. I could have an equilateral triangle. Let's check out their last side. So I've gotten down 1 and over 1, 2, 3, 4, 5, 6, 7. So this is 7 by 1. So right now, I know that AC is not going to be equal to AB or BC, but I'm still going to find the length just because that's what I've been doing. I got 1 squared plus 7 squared. And that's going to come up be the square root of 50. Okay. I can pop that in the calculator or recognize that I can write it this way. 25 the square root of 2, which is 5 the square root of 2, as an exact answer. It's a little bit bigger than 5, but it is not exactly 5. So my triangle is isosceles. So I have an isosceles triangle. So triangle ABC is isosceles. Okay, now we're going to move on to the next one. Okay, so I basically did one that you've done with me, and this is another triangle one. I am looking here, I'm going to go, hey, DEF has vertices D00, E14, and F52. Is DEF scalene, isosceles, or equilateral? And this should really have a triangle in front of it. So if you'd put that in there, I'd greatly appreciate it. Again, I included these formulas. Okay, and you can totally use the formulas. I'd be normally using the distance formula if I just used the points. But because I have this wonderful grid and they give me those points, I am going to use the grid. And I am looking at 1, 4, if I can get my grid up here. So let's see what we can do about getting that down so I can actually see things the way I need to see it. So we can talk about this with some sort of intelligence. All right, cool. Now, I'm going to put in D00, E14, and F52. D was 00, E was 14, and F is 52. So I've got those points. Now, my job here is to find the lengths of each one of these segments. Okay, so I'm going to start out with DE. And again, I'm going to use that Pythagorean theorem shortcut. I'm going to pretend that this is a right triangle and that this is my hypotenuse. So I'm 1, 2, 3, 4, 4, 1. So I got 4 squared plus 1 squared. And I'm going to move this one a little faster. Okay, I'm going to look at EF. Okay, and EF is 1, 2, 3, 4, 1, 2. So 4 squared plus 2 squared. Okay. Now, I'm going to look at the last one here, and I'm going to look at DF. DF is 1, 2, 3, 4, 5, 1, 2. That's 5 squared plus 2 squared. Okay, now, let's finish this out. I got 16 plus 1, which equals the square root of 17. Now, notice I'm not going to put that in my calculator because I know if they're all the same square root, they'll be equal. And I've got 16 plus 4. Okay, which equals the square root of 20. And I have 25 plus 4, which is equal to the square root of 29. What I have just learned is that this triangle is scalene. None of my legs or my sides are the same. So triangle DEF is a scalene triangle, meaning none of the sides are the same, and because none of the sides are the same, none of the angles can be the same either. Now, in classifying a parallelogram, whether a shape is a parallelogram or not, is whether the sides are parallel. So they're asking here in this problem, is parallelogram ABCD a rhombus? Now, this is important. They told me that this is already a parallelogram. So already I know opposite sides are the same measure. Okay, and opposite sides are parallel. So I know a lot of things that are going on with this. And right now, just looking at it, I am totally aware it is not a square. Okay, so I'm just got to find if because if it's a rhombus, I just got to prove that two consecutive sides are the same measure. And I don't care which one I'm doing, I'm just going to grab this one and this one just because those are the ones in my way. So I'm going to look at side AB, okay? And hey, I'm going to use that Pythagorean theorem shortcut that Bloom showed me because that's pretty quick because I've got a grid to deal with. So I'm going to look at AB and I'm going to look at BC. Okay, so I want you to do that on your own, shut it off, and see if you can come up with those answers yourself. So shut it off right now and do it yourself. Okay, welcome back. We've got this going on. Let's check this out. I'm going to remember a fake right triangle. Now I've got 1, 2, 3, 4, 1, 2, 3, 4, and 2. So I got 4 squared plus 2 squared. Okay, that's the square root of 20. I'm not going to reduce. I could 4 to the square root of 2. Excuse me. Not 4, but 2 to the square root of 5. Okay, if I go for an exact, but it's just the square root of 20 is what I need to know. Okay, because if it's going to be the same, then I'm golden. But here's the next one, and I've got up 1 over 4. 1, 2, 3, 4. So I've got 4 squared plus 1 squared. Now keep in mind, that's going to be the square root of 17. The square root of 17 and the square root of 20 are not the same, so it cannot be a rhombus. Okay, sides, I should say it this way, all sides not congruent. Opposites are congruent. Now, I've got some people going, Bloom, you didn't check all the opposite sides. I don't have to because opposite sides are congruent automatically in a parallelogram. So because all sides aren't congruent, because these two consecutive sides are not congruent, then all sides aren't congruent together, just the opposites because it's a parallelogram. So this is not a rhombus. Okay, it's a parallelogram. Okay, so keep that in mind when we're going through and recognizing what we're doing. I think we're done with this problem and we're going to move on to our next. Classifying a quadrilateral. Now, a kite is shown. Now, right now, they tell me it's a kite. Okay, what is the most precise classification of a quadrilateral formed by connecting the midpoints of the sides of the kite? No, that's something different. They tell me this is a kite, and they wanted me to connect midpoints and then classify off the midpoints. So the midpoint from here to here, so that's 1, 2, 3, 4, 1, 2, 3, 4. That's actually pretty nice and easy because halfway there is there, halfway is there, so that's a midpoint right there. Okay, and it's crazy that we can do it, but remember that's the midpoint of this leg and this midpoint of this leg, and if I connect them, I know that midpoint's there. This midpoint is here, and this is a quick graphic way to find midpoints. Now let's check out this one. I know this is the halfway above. Let's see if what the halfway here is. From here over 1, 2, 3, 4, 5, 6, 7, 8. Okay, and at 4 it's halfway, 1, 2, 3, 4, and hey, check out the midpoints can be right here, and it's going to be right here on that as well. Now, I always have folks going, wow, you did that really fast. How in the world can you prove it? And here it is for KY, my midpoint for KY, I've got 1, 2, 3, 4, 0, negative 4, 0, and I've got 0, 1, 2, 3, 4, 0, 4. Now, I want you to keep in mind that 0 plus negative 4, okay, and I'm not sure, divided by 2, and 0 plus 4 divided by 2 becomes negative 2, 2. Well, hey, what did I say that midpoint was? Negative 2, 2. Crazy that that worked so quick. And the other midpoints will fall in line. This will be 4, 2. This will be 4, negative 2. Okay, and this will be negative 2, negative 2. Okay, when I get those done. Those are my midpoints. Now, if I connect these, okay, I can actually find my shape's lengths. Right now, I know that I'm doing distance formula, but because they're vertical and horizontal, I know that this is going to be 4. I know that this is, if I count 1, 2, 3, 4, 5, 6, this is 6. 1, 2, 3, 4, that's 4. This is also 6. Now, I know it's a grid. I know it's an XY coordinate grid, and the horizontal and the vertical are perpendicular by definition. So I have in this thing. I know I've got my midpoints together. So I got my midpoints of KY, and I got midpoint of IT, okay, which is 4.2. And I got my midpoint of TE, which comes out to be 4, -2. And I've got my midpoint of KE. My midpoint of KE is also -2, -2. We know the lengths of stuff, okay? I've got lengths here. I want to make sure that people know that I know these lengths are the same, okay? I'm looking at my midpoint length. So I've got KITE, and I'll call this A, B, C, D. So my AB length is equal to the opposite side CD, which happens to be 4. I know my BC length, which is equal to my opposite side AD, which is 6. So I know opposite sides are the same length. Okay, are congruent. So right now I know that the shape that is formed is a parallelogram. Now I've got some folks saying, bloom, bloom, bloom. It's a rectangle. It's a rectangle. Okay. Well, here's the thing. I know that my slope, okay, and I've got midpoint in here and slope. So we're going to call this slope of AB, and my slope of CD are both undefined. Okay, vertical line. Okay, I know those for a fact. And my slope for my horizontals, my BC, I just want to make sure it's BC. Yep, my slope of BC, and those are segments, by the way. My slope of BC is equal to my slope of AD, and my slope here, and that slope is 0. So 0, okay? And it's defined that an undefined slope and a 0 slope are actually perpendicular. So all my angles are 90 degrees or right angles. So angle A, angle B, angle C, and angle D are all right angles. So parallelogram, or I should say, the parallelogram ABCD is let's do it this way. So the quadrilateral, let's do it like that. Quadrilateral, the quad ABCD, because that's what we did, made from midpoints. Is a rectangle. Okay, remember, opposite sides are congruent. All 4 angles are right. Remember, the opposite sides being congruent said it was a parallelogram. But all 4 angles are right means it's a rectangle. And that's what we're coming up with. Okay, so that's how I know the things I know about that particular shape. Okay, today's summary. Okay, keeping in mind our objective, students will be able to classify polygons in the coordinate plane, and we just use the coordinate plane equations. Okay, if you're given a grid, use it. It makes it much easier. Write a couple sentences about something that you learned today about the learning objective, and then rate yourself. And again, we have our quad sheet just in case you are unaware that these things existed. I want to make sure that you have all this information. Now, please keep in mind, we have filled this out on other days. So if you haven't, maybe perhaps you were gone, you are making sure that you've taken care and filled out this purple sheet that you get to use on your test. Okay. Now, those are all up. If you need a particular spot, run me back and stop it, and then write down what you need. Now, just like everything else, check with your scale on the front page and see what you know and see what you don't know. Check those things out. Now, And just like any other time, if you have questions, locate your local geometry teacher and ask them. And remember, I'm Mr. Bloom, and you're not.